Okay, we're going to run through the 8 rules of circle theorem, and I'll explain the rules one by one, and then we'll do a number of questions, about 10 or 12 questions on it, just to get used to using all the rules together. So, these are the first 2 rules. The first rule here, angles in the same segment and standing on the same chord are always equal. Now, there's the chord, okay, and standing on the same chord, so starting from one end of the chord, hitting the circumference, and down to the other end of the chord. Again, just to change the colour here, starting from one end of the chord, hitting the circumference, and down to the other end of the chord. They are all equal. Now, sometimes it's described as starting on the same chord or starting on the same arc. So there's the arc there, if it starts and finishes at the same points on the arc. Okay, and just to illustrate this below it, it can be, so if you start here, up to the circumference, and down to here. So if you don't have the chord in it, you just have the arc. Just say that angle is x. Well, then an angle, starting at the same place, hitting the circumference, and ending at the same place, is the exact same size. Okay, and no matter where you go straight over here and down. As long as you start and finish at the same points and you hit the circumference, the angles are the same size. The second rule here is where you've got starting from the same arc or chord again, and one hits the circumference and one hits the centre of the circle. Okay, the angle at the centre of the circle is twice the angle at the circumference. So if you have x at the circumference, the angle at the centre is 2x, and it's shown up here in the diagram with a double line on the angle. It's twice at the centre than it is at the circumference. Okay, so that's the first 2 rules. Now, the angle in a semicircle is always 90 is rule 3. Now this is actually the same as rule 2, previous rule, that the angle at the circumference is twice at the centre. So if we take 2 points on the circumference, so one hits the circumference there, and one goes through the middle. Now, just because it's a straight line, we know a straight line is 180. So it's double at the middle than it is at the circumference. So the one at the circumference is 90. And it's usually shown in a rule of its own. So if you've got a triangle that goes right through the diameter and hits the circumference, the angle at the circumference is always 90 degrees. Rule 4, a cyclic quadrilateral. Now, the opposite angles of a cyclic quadrilateral add to 180. Now, you're going to get some questions where you will have 2 quadrilaterals inside it. A cyclic quadrilateral, all 4 vertices, which is the corners, must touch the circumference. Okay, so any 4-sided shape where all 4 corners touch the circumference. Okay, so if you have something like this, I'll take this out. So you've got, that is not cyclic because this corner doesn't touch the circumference. So in a cyclic quadrilateral, the opposite angles add to 180. Rules 5 and 6, straightforward. A line drawn from the centre of the circle to the midpoint of a chord is perpendicular at 90 degrees. Okay, so you've got the 90 degrees here from the chord, the centre, and the centre of the circle. But this one here is one of the most popular ones. A radius and a tangent will always meet at 90 degrees. So, you have a radius of a circle, and a tangent that comes. The tangent is a straight line that touches the outside of the circle. It will always meet at 90 degrees. Okay, that rule comes up all the time. And the last 2 rules, tangents from a common point outside the circle are always equal in length. Again, this is a key rule that comes up in the exams every year. So, if we have tangents from the same point outside the circle, so we'll take this point out here. So, a tangent from, that's meant to be a straight line, I'll do that again. Okay, tangents from the same point are equal. Now this is key because if you have the centre of the circle, what you can do once you see tangents from the same point is, you know, radius or radii, 2 radius are equal as well in length. So if you've got 2 equal sides here in the orange and 2 equal sides in the tangents, you've got a kite. And when you have a kite, you can always split that into 2 isosceles triangles. Okay, so you know if you've got the angle at the top of this triangle, the bottom 2 angles are equal in an isosceles triangle. And again, on this angle from the radius, if you've got the top angle, the bottom two angles are equal. Also known that tangents and radius meet at 90 degrees. Okay, so once you get the bottom angle from this first isosceles triangle, you can take it away from 90 to get the bottom angle from the second one, and that comes up all the time. And the very last rule is a theorem. It's called alternate segment theorem, and it clearly states that if you have a tangent and a triangle, and again I know it's drawn for you, but just drawing it here again, if you have a tangent that meets a triangle at a certain point, the angle between the tangent, hold on a second, the tangent and the chord is equal to the interior opposite angle. So there's the interior angle in the triangle, and the opposite is up along the line. Okay, and then we go in here to the, we'll not use red, we'll use blue. So this angle here is equal to the interior opposite angle, and that's alternate segment. Okay, so we're going to go through 10 or 12 questions on this, and I'll get you to pause on each question. So just get on to the first one. If you want to pause at this point and try and answer the question, unpause, and I'll go through the answer. Okay, we're asked to find the angle ACD, which is this angle in here, and it's straightforward. We can see we start at A, up at the circumference, and hit D, so that angle is 54. We start at A, up at the circumference at C, and hit D, so that angle must be 54 degrees too, and that's using the first rule. When it says give a reason for your answer, you explain the rule. So angles from the same arc or from the same chord are equal. Angles at the circumference from the same arc or chord are equal. Again, pause, work it out, and unpause for the answer. Okay, we can see we've got an angle at the centre, so automatically we think of our centre rule. We know that angles at the centre are double angles at the circumference if they start and finish at the same arc. So we're asked to find ADC, which is in here. Now we can't find this straight away, but what we can find when we look at the diagram, always start with the angle that you have and see what if you can get another angle off that. Well, we know up here will be half the size because of rule 2. There we have, starting and finishing at the same arc. The angle at the centre is double the angle at the circumference. So the angle at the circumference here is 84 degrees. So that's the first part. We now can see that we've got a cyclic quadrilateral. So if I draw in the cyclic quadrilateral in a different colour, there's a four-sided shape where all angles touch the circumference of the circle. And we know in a cyclic quadrilateral, the opposite angles are equal. So if this is 84, the opposite angle here is 96. So that's the 180. Next one, pause and unpause for the answer. Okay, this, we have a couple of the rules we can spot. We've got a tangent, two tangents starting from the same point on the outside, so we know that they're equal. We also have a tangent meeting a radius at 2 points. So the radius and the tangent here, we know they meet at 90 degrees. So we've got two right angle triangles. Okay. We also know that we've got two radius here, two radii, and they're equal. Radius are equal in length. So we've got what I was explaining is as our kite. Now we're asked to find DOA. So to find DOA, it's this angle in here. Okay, we're going to have to work out a few other things first. Well, let's take these right angle triangles, and we know they're identical. Well, if we've got 34 and 90, angles in a triangle, add to 180. So 34 and 90 is 124, and 180 take away 124 is 56. So in there is 56 degrees. Working out, this is the exact same, so it's 56 degrees. So now, angles on a straight line, add to 180. So in here is 56 plus 56 and take away from 180, which is 112, take away from 180 is 68 degrees. Okay, so a couple of steps in that, we're using 3 of the rules. Again, pause and unpause for the answer. Okay, again we've got a tangent, or two tangents starting from the same point outside the circle. So again we know they're equal, just like the last question. We can draw in our radius, or two radii, and again they're equal. Now we're told that the angle BAO, we're told that we have to look for BAO. BOC is 130. So in here, BOC is 130 degrees. Now, we're asked to find BAO. So BAO, which is this angle here, splitting in half. Okay, so it's BAO. So if we find BAC, we could just halve it. Okay, so let's try and find BAC. Now, split that into two isosceles triangles. If we have this top angle at O is 130, well the bottom two angles are the same. So angles of the triangle up to 150. So 150 take away 130. Add up to 180. So 180 take away 130 is 50. So these bottom two angles in here are both 25 degrees. Okay, because the bottom angles in an isosceles triangle are equal. We also know that tangents and radius meet at 90 degrees. So this entire angle here and here is 90 degrees. So if the entire angle there is 90 degrees, well then the rest of the angle, 25 from 90, which is 65 degrees. So they're 65 degrees down in there. And if they're 65 degrees, we add the two 65 degrees together and we get 130 and take away from 180 because we've also got a triangle here. And this top angle is 50 degrees. Okay, so finally, if we're to find BAO, which is just half of that, which is 25 degrees. Again, pause and unpause for the answer. Okay. Again, two tangents starting from the same point and the rule with the 90 degrees. So, first of all in this triangle, we've got all the angles add up to 180. We know those two sides are equal. So again, we've an isosceles triangle. So 180 take away 86 leaves you with 94. So the two bottom angles add to 94, which means they're both 47 each. Okay. And then moving on to the other rule, which tangents and radius meet at 90 degrees. So we know the entire angle from the tangent to the radius is 90 degrees. So if we know this part here is 47, x then has to be 90 degrees minus 47, which is 43 degrees. Next one is a bit trickier because we're using algebra, and you have to prove that angle ROS is 2x, but do it the same way using the rules, only with letters instead of numbers here, and unpause for the answer. Okay, we're asked to prove that ROS is 2x, so we're looking to find ROS. Okay, so we know that tangents and radius meet at 90 degrees. So that total angle is 90 degrees. Now we know the outside part is x, so to find this inside part, it is 90 minus x. So in here is 90 minus x. Now we know that this is an isosceles triangle, so both these sides are equal because they're both radius. So we know that the top angle here is also 90 minus x. Now angles in a triangle add to 180. So if we want to find the angle at O, ROS, it's 180 take away the other two angles. So it's 180 take away 90 minus x plus 90 minus x. Okay, so add the other two angles, take away from 180. So that's 180 take away, well 90 plus 90 is 180, and minus x is minus 2x. And getting rid of the brackets, that's 180 take away 180, and minus gives you plus 2x. 180 take away 180 is gone, so ROS is 2x, as we were asked to prove. Again, pause and unpause for the answer here. Okay, we've got tangent meeting the radius, so we know we've got 90 degrees there, and we've got excuse me, and we've got two sides of the rectangle. Now, the first part is explain why OAB is a right angle. Well, it's a right angle because tangents and radius always meet at a right angle, so you just put in the rule there. And now work out the length BC. Now, to work out the length BC,